Tunnels are one of the most impressive engineering feats of modern civilization. They allow us to carve through mountains, pass beneath oceans, and connect places that would otherwise be isolated. Whether for roads, railways, or water systems, tunnels play a crucial role in shaping the world we live in. But how do we build these massive underground passages? What does it take to carve through solid rock and soil while ensuring everything stays safe and intact? Today, we're going to follow the step-by-step process of building a tunnel from start to finish. Let's get started. Before any digging begins, the first and most important step is planning. Engineers and geologists spend months, sometimes years, studying the terrain to determine the best route for the tunnel. They need to answer critical questions. What kind of rock or soil will they be digging through? Are there underground water sources that could cause flooding? Will the tunnel pass near fault lines or other geological hazards? To get these answers, teams conduct extensive surveys using advanced technology. They drill deep boreholes to extract samples of rock and soil, analyze them in laboratories, and even use ground-penetrating radar to create detailed underground maps. This information helps engineers decide on the safest and most efficient way to dig the tunnel while minimizing risks. Once the terrain is fully studied, the tunnel's exact path is mapped out, and construction crews prepare the site. Temporary roads and access points are built, and massive machinery is transported to the location. With everything set, excavation is ready to begin. Digging a tunnel is a complex task that depends on factors like soil composition, rock hardness, and depth. To overcome these challenges while ensuring stability and safety, engineers rely on different techniques. For simple tunnels, the cut-and-cover method is used. For very deep tunnels, bigger and stronger machinery is employed. And for harder tasks, explosives can be the way to go. Now let's take a closer look at these methods. For shallow tunnels in soft soil, workers may use the cut-and-cover method, digging a trench, constructing the tunnel inside it, and then sealing it beneath the surface. This technique is effective for urban areas, where tunnels need to integrate with roads and buildings. The tunnel boring machine is a massive piece of equipment with a rotating, cutting head that grinds through rock and soil, deleting everything in its path. As it advances, it doesn't just excavate, it also reinforces the tunnel walls, creating a smooth and stable structure in a single continuous motion. For particularly hard rock, engineers turn to drilling and blasting. This method involves drilling a series of holes into the rock face, filling them with precisely measured explosives, and detonating them in a controlled sequence. The explosion fractures the giant rock formations, making them easier to remove. After each blast, heavy machinery clears away the debris. Regardless of the method, as excavation continues, crews work in shifts around the clock. Ventilation systems are installed early to ensure fresh air reaches the work site, and constant monitoring helps detect any shifts in the ground that could indicate potential risks. Once the tunnel reaches the other side, after months or even years of hard work, the basic passage is complete, but it's still just a rough, unsupported space. To ensure long-term durability and safety, the next phase begins: reinforcement. Once excavation is complete, the tunnel must be reinforced to prevent collapse from the surrounding soil and rock. This is done by installing a lining made from concrete or steel. Precast concrete segments are often used, delivered in large pieces that interlock to form a strong, consistent wall. The benefit of this method is that it is made along with the excavation process. As the tunnel boring machine moves forward, these segments are placed into position to create a sturdy, watertight barrier. In some cases, shotcrete, a type of sprayed concrete, is applied in layers to reinforce the tunnel further. This helps create a smooth and durable surface that can withstand pressure. For tunnels in water-prone areas, waterproofing is essential. Membranes or sealants are applied to prevent water infiltration, ensuring the tunnel remains intact for years. Reinforcement and lining take time and careful work, often taking months to complete. Once finished, the tunnel is structurally secure and ready for utilities and final touches before it's truly ready for use. After the tunnel is lined and reinforced, The next step is installing the crucial systems that will ensure its safe operation. This phase involves integrating various infrastructure components that allow the tunnel to serve its intended purpose, whether for transportation, utilities, or more. Lighting is a top priority, as tunnels are naturally dark environments. Efficient, long-lasting LED lights are installed throughout, providing clear visibility. Ventilation systems are equally essential. With no natural airflow underground, tunnels require complex ventilation to provide fresh air and to remove potentially harmful gases like carbon monoxide. In tunnels designed for transportation, the installation of rail or roadway systems follows. For subway tunnels, workers lay down tracks with extreme precision, while for road tunnels, careful attention is given to creating smooth, durable surfaces with proper lane markings and road signs. These systems are vital for ensuring smooth and efficient travel through the tunnel once it opens. Fire suppression systems, alarms, and emergency lighting are installed to handle potential fires or other dangers. Additionally, communication systems are set up, allowing for real-time monitoring and coordination in case of emergencies. With everything in place, the tunnel is now ready to serve its intended purpose, offering a safe, reliable passageway for years to come. So that's how a tunnel goes from a concept to a fully operational passageway. It's an incredible journey that involves a blend of planning, advanced technology, and hard work to bring it all to life. Tunnels are a vital part of the infrastructure that keeps our world connected. If you enjoyed learning about how tunnels are created, be sure to like, subscribe, and leave a comment below. Let me know if there's anything else you'd like to know, and I'll see you in the next video.